You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hello folks, welcome to Azure AI Fundamentals. This course serves as a brief introduction to artificial intelligence, or AI, and how we can use some Microsoft Azure services for fulfilling our AI requirements. The topics that will be covered today map directly to the AI-900 Azure AI Fundamentals examination. It is ideal if you have a basic understanding about Azure and the cloud in general. Since today's content will be predominantly about AI, if you're completely new to the cloud, I would recommend that you attend the AZ-900 Azure Fundamentals course to fill up some gaps in your learning. The Azure Fundamentals course covers more generally the cloud concepts, services available on the cloud, and the advantages of working on the cloud. Before we begin, let me share a little bit about myself. My name is Rama, and I am a Microsoft technical trainer from Singapore. I'm a former automation engineer who transitioned into teaching Azure, and I love my job because of the amazing people I get to interact with and learn from every single day. I enjoy playing football, listening to music, and climbing mountains. So if you're ready, my job today is to help you conquer your own peaks by helping you prepare for the AI-900 certification. Please note that this course is supported by materials on Microsoft Learn. You can refer to aka.ms/azurelearn_AI fundamentals. The content there serves as a revision for the examination, closely mirroring what I will be covering in today's session. And on the slide, you can see the content that we will be covering for this course over 4 modules. In Module 1, we'll start with an introduction to AI, where we will discuss basic AI concepts, AI workloads, and principles of responsible AI, followed by a brief introduction to AI services in Microsoft Azure. In Module 2, we'll discuss machine learning. What are some applications of machine learning, different types of machine learning algorithms, without getting too deep into the weeds about the math. And we'll briefly touch on the concepts of regression, classification, and clustering. Nothing too complicated. We'll also look at how some of these can be implemented on the cloud using the Azure Portal and the Azure Machine Learning Studio. In Module 3, we'll get into a major application of AI, which is computer vision. We'll get an insight into how computers interpret the world visually and the services on the cloud that we can use to fulfill our workloads. And finally, in Module 4, we will learn about natural language processing, also referred to as NLP. NLP is how computers interpret written or spoken text, and we will see some applications of NLP such as conversational AI and bots that make use of conversational AI to interact with customers. The goal for this fundamental course is for you to be able to identify and describe AI concepts and their related Microsoft Azure services. By the end of these 4 modules, I want to give you a broad understanding of AI workloads, along with the tools and technologies to help you accomplish them on Azure. We'll be going through some demos throughout this class, and you can find the instructions for this lab at the GitHub repo associated with this course at aka.ms/AI900labs. Let's move on to Module 1, shall we? In Module 1, we'll be presenting this over 2 lessons, starting with a brief intro to the concept of AI. And then we will move on to discuss AI in the cloud, and more specifically, Microsoft Azure. In the first lesson, we'll have a brief introduction to AI, and I'll be sharing the definition of AI, some common workloads that we can carry out using AI, and finally, a very important topic. We will discuss the principles of using AI in a responsible manner, the challenges and risks involved when deploying AI. With the increasing role of technology in our lives, practicing AI responsibly has become crucial. What is artificial intelligence? Artificial intelligence is the science and engineering of making computers behave in ways that we, until recently, thought required human intelligence. So imagine AI to be no different from a baby. So when a baby is born, she starts to make sense of the world through her senses and absorbs any information that is provided to her by her parents. They point at an animal with 4 legs and they teach her that it's a dog. And she might initially think that everything with 4 legs is a dog. An elephant, a cow, a giraffe, maybe even a chair. And then we provide her with more information to supplement what she already knows, to help her distinguish between all things with 4 legs. And she learns to tell the difference across all of these 4-legged creatures and items. AI is a bit like that. This is the process that we are trying to emulate for computers, so that computers can start to carry out some laborious, repetitive tasks on our behalf. There are several human capabilities that AI can imitate. Let's look through some of them. Humans are very good at making predictions or recognizing patterns using available information and experience. On days that it rains, we might notice that the air conditioning inside the building is a little colder, so we might raise the temperature in response. So provided with that same data and past outcomes, computers can learn how to make these predictions by recognizing those same patterns. We'll talk more about this in later modules. Humans are also very good at intuitively knowing when something isn't quite right or doesn't fit an expected pattern. Perhaps when your usually noisy kids are being surprisingly quiet and well-behaved, you might want to start looking around the house to see if something's broken. Software can also take over this job from us because they are very good at spotting anomaly. And we can build in automation to start workflows based on such anomalies. Humans use sight to experience the world visually, and we can recognize people and landmarks in a photo. Instead of eyes, computers have cameras that allow them to receive this input, and they can analyze images and videos. We can also communicate by writing and speaking and engaging in dynamic conversations, having to respond appropriately. Software can now do this quite well. We see chatbots interacting to answer common queries, engaging in dynamic conversation to provide you with the relevant information based on your query, and playing the right songs based on your request. Finally, we are also very good at extracting information from multiple sources to extend our knowledge. We can see an image of Mount Everest and connect it to documentaries or movies or facts about Mount Everest that we've come across. AI can also make these connections across multiple databases and sources to connect this information that used to be stored separately and queried separately. Now they can be queried at the same time. However, since your time and mine is better spent on more value-adding activities rather than things that are dull, difficult, and repetitive, it is a good idea to outsource these tasks to our machines using AI software. Imagine a future where you can do your online shopping or catch up on some reading while your self-driving car brings you to your location. This table below shows the human traits that I just described and how they can be carried out by software. For the rest of this course, we will be going in depth into each of these types of workloads. And a lot of AI work is about providing data models with good quality data to be able to train these computer software and build deployable models that can then spot those patterns in unseen new data to make predictions. So let's first start with machine learning, where our aim is to create predictive models based on data and statistics. It is the foundation of artificial intelligence. A possible application of this could be to build a model to predict housing patterns. If I was selling real estate, from experience, I know that apartments on higher floors tend to fetch a higher price. But if I wanted to know exactly how much more a house on the 9th floor costs as compared to one on the 8th floor, I can train a machine learning model based on past transactional data. A fairly simple model that can be made more sophisticated based on the quality of the data available. We will see one such example in Module 2 a little later. Next, anomaly detection. It's about detecting unusual patterns and behaviors. And it should be noted that this is about detecting something that is very rare in the data. A good example to think about is credit card fraud. Let's say I purchase something at a grocery store near my home in Singapore, and 2 minutes later, another transaction is attempted at a shop in Canada. That is something that is very strange compared to my usual credit card behavior. So the algorithm is probably going to say something like, uh-oh, something's going on, and flag this anomalous behavior and block the suspicious transaction and maybe my card. Sometimes this can backfire. It might be a scenario where you're simply on vacation and using the card on the other side of the world, and the algorithm ends up flagging your legitimate activity as suspicious. Algorithms are, of course, not perfect, but they get better as we train them with higher quality data and more data. Computer vision has some common applications that we probably have already seen in the papers or heard in the news. Things like facial recognition, object and distance detection on self-driving cars. It can also be used in manufacturing lines for sorting, quality control, and workplace safety. Natural language processing, or NLP, that's one of my favorite applications. And it has so much potential. We are already experiencing the benefits of NLP on a daily basis without even realizing it. Spelling and grammar checks on your text editors, spam filters in your email, voice assistants on your smart speakers, phones and watches. As you provide more and more input, be it verbal or textual, the machine uses NLP to respond accordingly. And finally, knowledge mining is an emerging discipline in AI that allows organizations to deeply understand and explore their information stored across several databases and uncover hidden insights to find relationships and patterns at scale. This is something that has massive potential for application in marketing. And these are 5 distinctive AI workloads. And while building out a solution, you might have a combination of these workloads. For example, imagine a conversational AI solution that uses a bot to process an auto insurance claim. The bot relies on some natural language processing capabilities to make sense of input, such as, I want to submit a claim. It may allow users to send a photograph of a damaged vehicle, and using computer vision, it would assess that damage and apply a machine learning model to predict likely repair costs. And the bot might also use anomaly detection to identify potentially fraudulent claims. Finally, the claims data, including forms, photographs, and other artifacts, might be indexed to extract insights and create a searchable knowledge store to help manage future claims. At Microsoft, when we develop AI software, we are guided by a set of 6 principles. Everything that we are discussing with regards to Microsoft Azure will have these principles baked into their software and operations. Since we are using AI to tackle some of the biggest challenges known to humankind, we need to be responsible since there are challenges and risks that come with AI. Also, these will come up in your examination, and I will make sure to understand the differences across them really well. First, fairness. AI systems should treat everyone equally. Suppose you have a loan approval algorithm for a bank. The model should make predictions of whether the loan should be approved without incorporating any bias based on gender, ethnicity, or any other factor, right? Because it might disadvantage a specific group, and that's not fair. However, if a loan approval model discriminates by gender due to bias in the data using which it was trained, in the past, maybe there had been an implicit bias in the way that human loan officers gave out these loans. If we feed this wrong data of accepted and rejected applications based on past results to train the model is also going to behave the same way as these biased loan officers and continue to propagate those biases. And we want to avoid this because everyone is equal and we do not want to continue making the same mistakes from our past. So models need to be rectified to eradicate such biases so that we do not disadvantage any groups. You can tackle such biases on Azure Machine Learning since it includes the capability to interpret models and quantify the influence each feature has on the prediction model. That way you can analyze each feature, its level of influence on the outcome, and determine if there is any cause for concern and tackle those biases. Second, AI systems should be reliable and safe. Otherwise, they should not be encountering human beings and putting them at risk. We have been hearing all this news about amazing autonomous vehicles that can park themselves, stop at red lights, obey speed limits. But let's take a situation where an autonomous vehicle is fed some bad data, or encounters a system failure, or perhaps it is unreliable in making decisions when the camera does not have sufficiently clear photos. Should this car still be allowed to be driving on our roads alongside humans? We might be causing substantial risk to everyone on the roads. That's why AI-based software development must be subjected to rigorous testing to ensure that it works as expected before it gets released. Next, we must ensure that AI systems are secure and respect privacy. This is because some of the large volumes of sometimes sensitive data that AI-based software has access to and are trained with could be highly sensitive, and there could be personal details that must be protected. Since we are using hard data to train these models, it is also possible for hackers to gain full access to the original data. Let's say a medical diagnostic bot is trained using sensitive patient data and their diagnostic scans, and the data perhaps is not stored securely or encrypted. If hackers get their hands on the data, it could be very damaging and prone to abuse. And that is why there is so much focus on anonymization and data privacy, and multiple levels of security for such sensitive data. Fourth, it is important for us to keep inclusiveness at the forefront. There are many solutions that improve the lives of many people, and it is easy to sometimes overlook circumstances where not everyone is able to benefit from that solution. AI systems should always empower, engage, and benefit everyone in our society, regardless of education, orientation, gender, socioeconomic status, or physical ability. And nobody should be systematically left out of being able to enjoy these benefits. Let's take the example of perhaps a predictive keyboard application that I use on my phone on a daily basis. I cannot imagine being without it right now. It has allowed me to spell complicated words by pure guesswork. But that application does not have audio output, so visually impaired users may not be able to access it. Next, AI-based software should be as transparent and understandable as possible. Users should be kept informed of how their data is being used, the purpose of the system, how the application is generating the guidance and advice, and be open with customers about the limitations and expectations. This way, customers can make an informed decision about whether to participate. Imagine we have an AI-based financial tool that gives you investment advice. Should we just follow it blindly because someone put the AI tag on it? The tool might be controlled by some bad actors who are manipulating large groups of investors to take their money. So we should be very careful. And finally, designers and developers should work within the frameworks of organizational principles and governance to ensure that their solutions meet clearly defined ethical and legal standards. If you've worked with code before, sometimes you don't know why your code works, but it works. And we don't want to change anything. I was the same way in school. But we cannot take the same approach with AI because the stakes sometimes can be much higher. And we need to know exactly why something works in a certain way. Someone has to be accountable for that solution. When nobody is accountable for these AI-driven decisions, things can go south really quickly. Imagine an AI-driven court judgment putting an innocent behind bars. If we have offloaded that decision to an AI system and not considered all the facts, because no two decisions are the same, there's no way to feed all of the parameters involved in a case to an AI system. So who is responsible to say if the AI model identified the person accurately? In Lesson 2, I will be discussing how we can start to work with AI on the cloud, specifically Microsoft Azure, and introduce some of the tools available for you to get started building out your own AI solutions on Microsoft Azure. There are several reasons why working on the cloud can be beneficial, especially when it comes to using AI workloads. The main advantages of working on Microsoft Azure are scalability and reliability. What do I mean? The cloud offers almost an unlimited amount of data storage, whereas your own laptop or PC might just have a few terabytes of storage at best. Having a large space to host your data allows you the convenience of storing and using the valuable data that is vital for your AI application. And then we have compute, another key component for AI. Training a simple model might just take a couple of seconds. But as algorithms get more complicated, perhaps we're training an object detection or a facial recognition model, and the amount of data that we have to feed these AI training models increases. And this training might require an immense amount of processing power and time. Sometimes this can be in the scale of hours or even days if we're working with videos and using a normal laptop for training. However, we can cut this processing time down to several minutes on the cloud by deploying powerful compute resources on the cloud. Finally, there are some cutting-edge services available on the cloud for consumers to start developing their own solutions with minimal setup time and cost. So users do not have to spend much time worrying about the environments. They can simply deploy services on the Azure portal and get started developing their AI solutions right away. With that, let me now bring your attention to the diagram on the right. Let me start with the smallest unit in the diagram, resources. Throughout this course, we might sometimes use the word service and resource interchangeably, but both refer to the over 200 services that you can deploy and use on Microsoft Azure to build out your solution, which includes virtual machines, databases, AI services, many more. These resources need to be organized under resource groups, which can be thought of as organizational buckets. You can sort your resources into resource groups any way that you like, by resource type, the application that they're a part of, the department that created them. That's entirely your choice. But a resource group is compulsory before you can create any resource. And what's useful about a resource group is that there is a parent-child inheritance relationship between them. So I can use this relationship to govern or to control permissions on these resources. And also, once I delete a certain resource group, it automatically also deletes all of the resources inside. Finally, most important is that before you can get started creating or using any resources on Azure, you need to have an Azure subscription. In fact, you need to have an Azure subscription to do anything on Azure. A subscription is a billing and access boundary which lets you organize and manage your costs on Azure. So let me give you a brief tour of the Azure portal so that you have a better idea. Welcome to your first look at the Azure portal. So right at the top, you can see that we have a couple of services. Let me just walk you through some of them. These are the last few services that I've used. So anytime you are moving across different services, these will keep changing. And slightly lower down, you have recent resources that I've created. I've created some resources a few weeks ago, a few months ago. And then slightly lower down, you have some other quick resources that you'll be able to access. Things like your subscription, your resource groups, and then tools like Microsoft Learn, your Azure Monitor, which helps you to monitor the usage of your applications, your Microsoft Defender, which is like your antivirus or your protection for your environment. So what I want to bring your attention to is the ways in which you can navigate your way around Azure. So one of the ways that you can do that is using the hamburger menu at the top left. If you open this menu, you can see all of your favorites. And the advantage of having the favorites is that you can always reach them really, really quickly. And you can move them around. You can rearrange them as you feel, as you wish. So if you always use a lot of storage accounts, you can keep it higher up. If you use virtual machines a lot, you can also move it closer to the top. And if you clicked on all services, you'll be able to view all the Microsoft services that you can deploy. And these are the categories of services that are available on the cloud. So things like compute, things like mobile, storage, all of these are Microsoft-specific resources. And anytime you're lost on the portal, you can always click on the word Microsoft Azure and you'll be brought back to the home. And my favorite way of navigating Azure is using the search bar here. If I was going to look for something like, let's say, virtual machine, I'll type the word virtual, and you see anything with the word virtual, be it services by Microsoft, services in the marketplace, these are third-party applications, any of my resources with the word virtual in it, and most importantly, the documentation with the word virtual. So if you are interested in finding out what is, for example, virtual networks in Azure, you could click on this and it will bring you to the documentation about virtual networks and virtual machines. So the search menu, search bar is a very powerful way to navigate around Azure. Additionally, to the right of the search bar, you also have the option to open up PowerShell. PowerShell is a very powerful feature of Azure. Instead of using the graphical way to deploy resources, you could do it in a command line with a command line experience. And right next to that, you have your directories and your subscriptions, and you have various alerts and notifications that you can get from Azure. So when resources are being deployed, the notifications will let you know when they're completed deploying. And then you have additional settings. If you want to change your language, your currency, all of that, those settings are up here. And then you can also interact with Azure, with Microsoft to get any support or any troubleshooting done. And finally, you can also give some feedback. If you think there's something that could be done better or some things that are done well, you can provide feedback to Microsoft. And that won't be the last time that you'll be seeing the Azure portal. I will be carrying out several demos inside the Azure portal in the rest of today's session. Let's get back to the course material, shall we? And today we shall also be exploring the following Azure AI services. First, the Azure Machine Learning. Azure Machine Learning is designed for developers to train, test, deploy, and manage machine learning models from scratch, meaning they can experiment with data to make predictions. They can work starting from a data set and manipulate it to generate insight and predictions from that data with full autonomy on what type of model to use, how to make the predictions. And you're usually going to find data scientists and data analysts playing around with this tool. A major advantage of this tool is that you don't have to worry about spending any time setting up the environment. The moment you deploy the service, you can immediately start hacking and building out your solutions using the tools inside of the Azure Machine Learning environment. Second, we have cognitive services, which is a collection of services that can be categorized into 4 main pillars. These are vision, speech, language, and decision. These services enable your application, website, or bot to see, hear, speak, understand, and make decisions by building intelligent capabilities into what you're developing. You can add different types of cognitive features without requiring any development skills or data science capabilities, because Azure helps you with that by providing pre-built products that you can immediately use and deploy to help your products to see, hear, and speak. Third, we have the Azure Bot Service. The Azure Bot Service is focused on developing, deploying, and managing your intelligent bots in a single location. We've all probably had the chance to interact with chatbots on some websites. Spoiler alert, quite often it's not an actual human sitting and replying to your every request. It might be a smart robot customer agent that's generating replies based on historical conversational data and insight that it is drawing from interacting with you. A fun fact to know is that bots also have a feature that enables chit-chat, which gives them some personality and lets you exchange niceties like a human. They can respond to you when you greet them, for example, when you say good morning, or you can respond with things like, I'm glad I could help, when you say thank you. Finally, we have Azure Cognitive Search, which provides you with a rich search experience. Cognitive Search is a platform as a service, cloud search capability that lets you create search-enabled web, mobile, and enterprise applications. It connects to different types of data sources, understands them whether they are structured, unstructured, and makes them searchable. And that's a brief intro to the types of artificial intelligence products that are a part of Microsoft Azure's product offerings that we will be discussing for the rest of today's session. Don't worry if some of what I shared on this session was a little alien to you. We're going to go through them together in greater detail for the rest of the session. So stick with me. I would like to spend a little bit of time talking about cognitive services. Azure provides a set of cognitive services that encapsulate common AI workloads. Deploying cognitive services is probably the quickest way for anyone to add vision, speech, language, or decision capabilities to their solution, as they can take advantage of the platform that has been developed by Microsoft. These off-the-shelf cognitive services can help you develop a solution more quickly and with less specialist expertise. What I really want to highlight is that there are two ways for you to deploy cognitive services. You can either deploy it as a standalone resource specific to the service that you want to deploy, namely vision, speech, language, or decision. Perhaps you only want to create a resource to do language translation and nothing else. Then you could deploy that specific standalone purpose. Or you could also deploy a general cognitive services resource, which encapsulates multiple services. And you could use that same service to carry out computer vision workloads, speech workloads, language workloads, decision-making workloads. But why would you do that? There is no right or wrong method of consuming these services or building out the solution. Using a standalone service-specific resource enables you to manage costs and access to that service independently of the other services you may be using, while a general cognitive services resource enables you to combine all of your AI resources in a single Azure resource for centralized management. So regardless of the type of service you use, standalone or general, client applications will consume the services by connecting to a REST endpoint, which is a HTTPS address to which they can submit requests using a resource-specific key for authentication. A REST API is a way to interact with a computer or a system to retrieve information or perform a function. An API helps you to communicate what you want to that system so that it can understand and fulfill your request. So, in a computer vision application, you might send an API request with a photo and request the service to identify all of the faces within that photo. The cognitive service receives your request, understands what you require, and carries out the tasks and returns that photo to you with the identities of all of those faces that it located on that photo. So let me take you into the Azure portal to see how we can use some of the AI capabilities on Azure. For the first demo today, I'm going to be creating an anomaly detector resource. An anomaly detector resource, as the name suggests, spots anomalies in any behavior. So we'll see what kind of behavior will be spotted in this example. And as I said, there are several ways to navigate around Azure, and I'm going to search for anomaly detector using the search menu right here, the search bar at the top. And anytime you go into a resource, a category, at the top left here is how you'll be able to create this resource. So when you click on this plus to create, you'll be brought through a wizard. And this wizard will guide you step by step through how to create this resource. So for first things you need to have is a subscription. Without a subscription, you won't be able to do anything inside of Azure. And since we are creating a resource, you need to have a resource group. This resource group is like a bucket that holds multiple resources and can help you to govern this resource. So I don't have any resource groups at this point. I'm going to create a new resource group. I'm going to call this AI-900 Virtual Training. And this tick indicates that this name is a valid name. Click OK. I'm going to keep going. And I'm going to create this instance in the East US. It doesn't matter really where you create it. The performance is going to be quite the same. But usually you want to choose something that is closer to home for you. Let's say East US Anomaly Detector AI-900 Demo. And this is a valid name. So I got a check mark here. And I can go ahead and deploy this resource. So for pricing tier, I'm going to choose a free resource. since I'm not going to do too many transactions on this, and I'm going to go ahead and review and create this resource. So when I review and create this resource, it's going to check if all of the details I've indicated are valid, and I'm allowed to create this resource based on my subscription and and the location I've chosen. So it reviews everything and it says validation passed. Now I can create this resource. So I'm going to go ahead and do that. So now our resource has been created and we are ready to use this resource. So for that, I'm going to first go to resource. And at the overview, you can see the overall details about this anomaly detector, which resource group it is in, its current status, it's active, the location it's been created in, the subscription it sits inside, and the tier, the API type, all of that stuff is available for you to view in the overview. And then before I can use it, I need to be able to consume this resource. And you're going to be able to do that using the keys and endpoint. So these are the secret keys and the endpoint, which sort of serve like your password to be able to use this resource. Because if you had a paid resource, using this password does cost money. So that's why these keys are are kept hidden, and you should not reveal these keys to anyone. For this demo, this is a free resource, so it's not really a problem because there is a limit on how much you can use. And how am I going to consume this resource? I'm going to be using the Cloud Shell. The Cloud Shell, as I mentioned a little earlier, is up here. And open this. And it's going to take a while to request the Cloud Shell and obtain storage accounts and compute capabilities for me. So let's wait. I think we're ready to go. So we open PowerShell and we are going to download a couple of files from GitHub for that. For that, I'm going to copy the instructions from the lab. And I'm going to be cloning this repository into this folder, AI-900 virtual training. Oh, it's got to be together, virtual training. And this is going to take a quick while to clone this repository and allow me to use it. So now if the files are already loaded, now I can go and take a look at and modify these files. So inside of PowerShell, I'm going to be able to view this. This is where the files are inside AI-900 virtual training. This is a folder inside my storage. So I'm going to go and find the resource that we're going to use is detect anomalies. And detect anomalies, what we need to do is we need to obtain the keys and endpoint from our Azure Portals resource. So the resource up here, the key needs to be replacing this text over there. So let's try and do that now. I'm going to copy this and I'm going to replace this text. And I'm also going to copy the endpoint and bring it over here. And I think we're ready to go. We're going to go back to our command line and try and obtain this, try and consume this resource. So what I'm going to do is I'm going to navigate into this folder, cd change directory AI-900 virtual training. Now we're inside that folder. What we have to do is we have to run this script /detect anomalies. So this is the script which we populated with the key and endpoint. So the moment I hit enter, what we're going to see is that this is going to process a file that contains a series of dates and times and numeric values. Why is that important? So you can imagine this being a pressure cylinder where temperature is important, because if the temperature goes too high, the pressure goes too high and we could risk damage, for example. So what this does is it analyzes the trend of the temperatures and finds a point which is anomalous, one that doesn't Welcome back from the break for Module 2. I hope that you were able to grasp the concepts in the previous module quite well because we're going to build upon them in Module 2. So Module 2 is going to be divided into 2 lessons. In the first lesson, we'll get a brief introduction to machine learning. I'll refer to that as ML from now on. And we'll get a glimpse of 3 types of algorithms, namely regression, classification, and clustering. Following that, in the second lesson, we'll be looking at Azure Machine Learning, which is a platform for machine learning on the cloud that helps accelerate and manage the ML project lifecycle. And we'll see a demo of the automated machine learning functions in Azure Machine Lesson 1 will serve as an introduction to machine learning, and I'll be talking about the 3 types of machine learning, namely regression, classification, and clustering. But of course, it is difficult to talk about machine learning and data without some basic math. But my goal is not to teach you linear algebra or any sophisticated algorithms. I just want to give you a little peek behind the curtain and gain an intuitive understanding of how machine learning works. And this understanding will help you to visualize the more advanced machine learning applications. And you don't have to worry, you will not be required to carry out any intensive calculations to be able to build and train your own ML models. This is where Azure Machine Learning comes to the rescue. We will talk about that in Lesson 2. Before we jump into a discussion about machine learning, let's take a second to think about traditional programming. The idea in a traditional programming model is that a programmer, a person, thinks about what this program has to do, and they have to provide the code or the instruction or an algorithm to teach the computer how to execute a task. And any input we provide is subsequently going to go through that algorithm designed by that programmer, and that output is going to come out. It's like going through a set of instructions. Machine learning, however, is the creation of a predictive model by finding relationships in data. So in this instance, we are providing data which is both the input and the output to the computer, and letting the computer think for itself and come up with the algorithm. This algorithm, once again, is not done by the programmer. That is the machine learning model. So why do we need to do this? In our daily lives and work, you and I, we create a lot of data, massive amounts, in the form of things like social media. There's all these likes and comments, our text messages, the way we write emails, photos we take, images where we consume, sensor data in our homes, our thermostats, our air conditioners, our lights, all of these are creating data all the time. For example, and even when we drive, this list is never ending. So much data. And this data can be harnessed by data scientists to draw insight and train machine learning models. And that data sheds insight into how certain tasks can be automated. In essence, we use this data to train a machine learning model to power an AI-based software to carry out the jobs of the future. So machine learning is the foundation for most AI solutions. Let me walk you through an example of one such machine learning model. Imagine you're a botanist. So you go around collecting flowers and you study them. So when you used to collect 10, 20, maybe even 50 flowers a day, you could classify them manually, based on their species. You could study them and you could classify them. But as time goes by, you start collecting more and more flowers. You're collecting 200, 500 flowers. And there's so much more work to do in terms of classification. So we want to try and automate this process using AI to classify the specimen in future. So we observe that we can examine and classify various characteristics of these flowers. So things like the length of these petals, the number of the petals, could be the size of the stem, the color of that flower. We call each of these things features. The features are characteristics of that flower. And the flower samples belonging to the same flower or the same family will have some common traits. That is their identity. Identity, and we refer to identities as labels. Label is a keyword I want you to understand. So all the specimens labeled Rosa multiflora are going to have some similarities. Proportionally, they're going to be somewhat similar. Likewise for the Bellis perennis and the Tulipa. This is the raw data that we feed to train our machine learning algorithm. The features in the form of colors and measurements, and the labels in the form of the name of the specimen. When we combine these together, the algorithm is going to understand the relationships between the features and the labels. And the result is a machine learning model that now has an intuitive understanding of these three species of flowers and can predict the species. And when I say predict, it is going to pick up a new flower that it hasn't seen before, and if you give it the characteristics of that flower, it is going to give you the label or the identity based on the features that are fed into it. And in this case, we obtain a new specimen, we feed in the features such as the petal length, the number of petals, the color, and anything else that was used to train the model initially. And the model is going to provide you with a prediction on what it thinks the label of the flower should be. In summary, we're using past data of a human performing the task to teach a machine how to do the work in the future. This diagram provides a great overview of the types of machine learning that we will be looking at. There are two general approaches to machine learning. One is referred to as supervised, and the other is unsupervised. And the goal of both methods is to formulate a model or an equation that will be useful in trying to predict future labels as accurately as possible based on the features. Once again, labels is the name or the identity of that object. To have a good accuracy of outcomes for supervised machine learning, we need quality data with known label values that we can fit to a model. This can then be applied to new data for which we don't have the label values. Remember, labels are what we want to predict. This could be things like a house price, or identifying what image or what item is in an image, or whether someone is likely to default on a loan or not. So there are two types of supervised machine learning tasks. So first, I'm going to talk about regression. Regression is when you want to predict a numeric value. So this could be something like a price, a sales total, or some other measure. So let's take a second to help a fictional bike rental business, Hot Wheels Rental. Let's say Hot Wheels Rental is located at East Coast Park in Singapore, run by my dear friend Mr. Steve Seagal. Mr. Seagal wants to be able to predict how many bikes are going to be rented on any given day so that he can be prepared in advance. Before we can start to train this model, we need some data from him. And Mr. Seagal, with his great foresight, has been keeping track of the average temperature every day. This temperature is our feature. And most importantly, he's also been keeping track of the number of bikes that were rented, and that is our label. So recall, features are the characteristics and labels are the outcome in this example. So to help Mr. Seagal, I need to create a machine learning model to predict how many bikes are going to be rented given that day's average temperature. As we feed the data of past rentals and the corresponding average temperature to our machine learning model, a relationship starts to emerge. And that is the machine learning model that we want to provide to Mr. Seagal to plan his business strategy. In this example, we used only one feature for training. That's very simplistic and might not truly give us a very accurate picture. Typically, you would find several parameters being provided as features, being used to generate a more robust machine learning model. Other real-world examples of regression could involve things like spam detection in email, or weather forecasting, or housing prices prediction based on location, number of rooms, number of toilets, etc. Next, we have classification. Classification is another type of supervised machine learning in which we are trying to categorize or classify something. So hence classification. Recall, in regression, we were trying to get a numerical value. In classification, we want to obtain a category. So let's now travel to the other side of the world to assist a fictional clinic in Costa Rica, run by another dear friend of mine, Dr. Eva. Dr. Eva wants to help spot patients who are at high risk for diabetes, to intervene early and so that we can help patients manage this disease before it gets too serious. And Dr. Eva has gathered data from more than 1,000 patients over decades and hopes that we can put this to good use. And this data consists of features like height, weight, blood pressure, and so on. We don't need to worry too much about the details. The ML model will take care of that. And most importantly, we also need to have the labels for these patients, which is a yes or a no, represented by a 1 or a 0 value, depending on whether that patient eventually developed diabetes or not, while being monitored by Dr. Eva. 1 means they have diabetes and 0 means they do not. Our algorithm is going to learn from these past data points and provide us with predictions in the form of a probability value between 0 and 1 when we input the details of new patients. And our data scientists who are building this model will then have to determine a cutoff threshold value. So for example, if our cutoff value hypothetically, let's say, is 0.5, and our algorithm gives us a value of 0.65, which is above our cutoff value, this will be considered a yes, or will be rounded off to a 1, and that person will be deemed at high risk for diabetes. Whereas a value of 0.4, which is below the cutoff, will be rounded off to a no or a 0 value. So of course, no algorithm can be perfect. It can only give us a probability value, and we need to tune our threshold value by working with the subject matter experts and plan the training of the machine learning model to improve our accuracy and the usefulness of the model. In some applications, such as when it concerns health and safety, we might want to be a bit more cautious. So it might be preferable to flag someone as high risk wrongly rather than potentially miss someone who is truly high risk. So the amount of process with multiple algorithms to obtain the best result. Sometimes there isn't much exactness to it. We do a bit of trial and error. And then we train our model using just 80% of the data. This is the learning component of machine learning. We allow the computer to try and capture the relationship between the features and the labels in a model. Training is the action of iterating on an algorithm to best capture those relationships. And after completing the training in step 3, we have a model that has established a relationship between the features and labels that we can now test. Remember the 20% of data that we set aside? It is known as the test data. So if you see the diagram on the left, you see an arrow under the number 4, which indicates that this is from the initial data set that we have. This is the 20% that we didn't use for the purpose of training. We can now use it to test how closely our model's predicted labels are to actual labels. This serves to grade our model's performance. And in the case of unsupervised learning, where we don't know the actual labels, we measure how well our model's predicted labels were at separating clusters. And there are many types of evaluation metrics. The important thing to remember is that the goal of machine learning is to find a model that gets as close as possible to predicting the actual label. The best model can still have some margin of error. It is never going to be 100% perfect. Based on how comfortable we are with the evaluation metrics, we can make some tweaks and changes and repeat that process, restarting from step 1. And that is the end of lesson 1. Moving on to lesson 2. In this lesson, we'll be talking about Azure Machine Learning and what Azure Machine Learning is. We'll look at automated machine learning and get a brief introduction to the designer as well. But first, let's understand what is Azure Machine Learning. Azure makes it very simple for you to use and execute machine learning workloads on the cloud. But before you can do that, you will need an Azure subscription. A subscription can be thought of as a billing and access boundary that lets Azure know how you'll be paying for the services that you're deploying. And it also allows organizations to control and govern who is allowed to create, access, and delete resources on the Azure cloud. And inside the subscription, you will need to create an Azure Machine Learning workspace. We'll shortly see how that is done. A workspace can be thought of as a logical container for resources that you need to manage machine learning projects. And the first of these resources is compute. Compute is needed to run machine learning workloads on the cloud instead of in your local computer. Running large machine learning workloads on your computer could take days or even weeks at times based on how much data you have. On the cloud, you have almost unlimited processing power, and that helps bring down the amount of time required to train your machine learning models. Next, you'll need your data. Your data is vital to build machine learning solutions. Managing data means being able to handle large volumes of data, but more importantly, also allowing it to be easily accessed for the purpose of being used for training your machine learning models. And every time you have a hypothesis on how to build a certain model, you will need to run a job to test it out. In the past, data scientists might try different algorithms and approaches to solve problems in a variety of ways. And a couple of days later, they might realize something I did a couple of days ago accidentally gave me best results. I'm sure I wrote it down somewhere on a napkin. Now, where is that napkin? Azure Machine Learning tracks every job that you run so that you can easily keep track of the different conditions of each experiment. So you can go back in time to see what were the conditions that got you the best results instead of keeping track of napkins for your variables. And next we have models. Experiments are used to train models, which you will register and manage in your workspace. These models can then be hosted and published for your consumption directly from Azure. And when you're ready to use your models in your applications, you can publish them as services that can be accessed over the public internet. In a while, I'll jump onto the Azure portal to give you a quick tour of the key areas and functionality of Azure, and then talk more about the machine learning capabilities that you can deploy on the portal. Inside the Azure Machine Learning Studio, we have Azure Machine Learning Designer. The Machine Learning Designer is a visual tool that we can use to create an ML pipeline. What are pipelines? Like it suggests, when water goes into one end of a pipe, it comes out the other end after traveling through the entire path, whichever way the pipe goes. And in Azure Machine Learning, pipelines are multi-step workflows that can help you to prepare data, to train models, perform model management tasks, anything that you require for that process. The Designer tool in Azure Machine Learning Studio enables you to create and run pipelines by using a drag and drop easy visual interface like the one that you see on the image on the right. It allows you to connect modules that define the steps and the data flow for that pipeline. By building out pipelines, we automate future processing of any new data that is coming into that pipeline. On the right side of the screen, you can see an example of a training pipeline. Let me walk you through that process. This pipeline starts with a data set. And in this case, that data set contains patient data and information about whether they have diabetes or not. And before we carry out any training for machine learning, data is usually pre-processed to clean it up and make it more suitable for building a model. And in this case, the numeric features in the data, things like height, weight, diastolic blood pressure, and so on, are normalized. And normalization means to convert them all to be on the same scale to prevent any one factor from being overly influential in deciding the label. And this is a common pre-processing step for numeric features. And the designer includes a normalized data module to do it without having to require any coding or programming knowledge. Next, we see a split data module. Split data is used to randomly split the data set into training and test subsets. This is also another common step in supervised machine learning pipelines. It allows you to evaluate the model using data that it has not been exposed to. The training subset is then connected to a train module, which in this case will fit the data to a function that predicts a diagnosis of yes or no for whether someone has diabetes. This is a classification function with two possible classes. So an appropriate classification algorithm must be used to train the model. And in this case, we see that the two-class logistic regression model was used. Some of you may caught that the word regression appears in the algorithm, but rest assured, this is a classification method. After training, we add another module. This module is used to score the validation data. In other words, we use the trained model to predict labels from the features. So the test data that we initially set aside includes the actual label value. So when we try to make predictions on that, we can see how close we actually got to the actual value. So when we use the score module, we can compare these two values using the evaluate model module to calculate the metrics to help us determine if the model is performing well or not. For a classification model like this, these metrics include simple accuracy as well as a confusion matrix of true positives, false positives, or true negatives and false negatives, from which other more discerning metrics can be derived. The other tool inside the Azure Machine Learning Studio is automated machine learning, which is the easiest way to train a machine learning model for supervised machine learning, where the features and labels are both provided. So models like regression and classification. Automated machine learning provides users with an easy-to-use visual interface to carry out machine learning operations, requiring little to no coding knowledge. Normally, to carry out the same operations, data scientists and data analysts would need to tweak certain features, have a good grasp of sophisticated computing and statistics knowledge. With AutoML, the user just needs to provide the training data and select the required model type. And AutoML does the rest. The best way to see how powerful this tool really is to jump into the demo and try it out. And that's exactly what I'm going to do. And now let me take you through the process of creating an automated machine learning resource inside of Azure. For that, I'm going to search for that machine learning, Azure Machine Learning, And I can select this resource right there. And to create any resource, always just look on the top left over here. Right now I don't have any workspaces to display. I'm going to create a new automated machine learning workspace using the existing subscription. I'm going to place this in the same resource group. For the workspace name, let's just call this AI-900 Virtual Training Demo. As long as you see a check mark, this name is accepted. And I'm going to create it in the US region, in the East US region. And when you're creating an Azure machine learning workspace, you're automatically going to be getting things like the storage account, the key vault, application insight. Because for machine learning to work, you do need a lot of, you do need the storage account because you need a place to store your data. Because without data, you can't train a machine learning model. And you're also going to get the key vault, which is going to help store your sensitive information. And you're going to get application insights which will store information about your deployed models. So these are things that are automatically created, so you don't have to worry about them. And they will all go into the same resource group. With those settings in place, I think we can go ahead and create this machine learning workspace. Let's review and create. And once you click review and create, it is going to validate if you are allowed to create this resource based on your subscription and your permissions. So mine, it says the validation passed. Let's go ahead and create this resource. Now our resource has been created. Let's go ahead and jump right into it. When I click go to resource, we are brought to this page, which is the Azure Machine Learning Workspace that we created. To use this resource, we need to click on Launch Studio. When we launch Studio, we are brought to a different section of this website, which is different from the Azure portal. So this is the Azure portal, and this is my Machine Learning Studio. And the Machine Learning Studio is where you're going to be controlling all of your machine learning assets. Things like your data sets, the jobs and experiments that you run, various components, the pipelines that you create, the models that you're ready to deploy, the endpoints that are being deployed. And right now, this is an empty Machine Learning Studio. So let's go ahead and create some resources. So to run any machine learning experiment, we do need compute. And that's what I'm going to create first. I'm going to go ahead and create a compute cluster. Let's create a new compute cluster. And I'm just going to place this in the East US again, like all my other resources. I'm going to have a dedicated virtual machine of a CPU type. I don't need that much processing power, so I don't need a GPU. And I'll select this DS11 because it's sufficient for my needs. And I'll click Next. And for the compute name, I'm just going to call this AI-900 Virtual Training Compute. And I'm going to have a maximum of 2 nodes. So these are 2 compute nodes working at the same time. That's what I want. And I can go ahead and create that. So this will just take a short while to create. In the meantime, let me show you around the studio a little bit. Next, we need data. So for the machine learning experiment that we're going to run, we're going to be predicting bike rental data. So let me bring up that data real quick. This is how the data looks. So we have information about the day, month, year, where there's a shop that is renting out bikes. So this is the actual number of bikes that they rent out at different days of the year and the conditions that were present during those days. So they've collected all of this data and they hope to use this data to make some predictions in the future of how many bikes they would need to have on standby on different days based on different conditions and different temperature and humidity. So let's bring this data set into our machine learning studio and see how to run this experiment. So I'm going to create this data set from a web file. This is a publicly available file at this URL, aka.ms/bike-rentals. I'm going to name this bike rentals. And this is a tabular data as we saw in the Excel file a little earlier. And let's just describe this as bicycle rental data. So we need to do a little bit more configuration before this data set can be accepted. So right now the portal is understanding this data, figuring out how it can be used. So it's checking with me if indeed it is a delimited file format. And it is, so basically the file looks a little bit like that. All of those values are separated by commas. They don't actually look like a table, but Excel is able to understand this data and display it as a table. So the encoding, I'm not going to change that. Column headers, and I'm not going to skip any rows. With that, I'm going to click next. And this is the schema. The schema is every column that you saw a little earlier, the day, the month, whether the type is correct. So all of them, it says integer, decimal dot, integer. So this seems fine. It has read the data quite accurately. And I can go ahead and click next. Once I confirm the details, I can create this data set. And it's going to be imported as an asset into my machine learning studio. So this is just going to take a while. Meantime, I'm going to create an automated machine learning experiment. So you can create an automated ML without writing a single line of code, and that's what I'm going to show you right now. So let's go ahead and create this new automated ML job. And this data asset has already been loaded. I'm going to choose this bike rental data and go next. And we need to do a little bit more configuration to set up this automated ML job. I'm going to call this MS Learn Bike Rental. And the target column is basically the answer that you're trying to find. This is what the model will be trained to predict. And in this case, we are trying to predict the number of bikes that are going to be rented based on any given condition. So this is the column we need to choose as our target. And the compute, I'm going to use the compute cluster that I just created. This is basically what is going to crunch our numbers and build this model for us. So this has already been created that we just saw a short while ago. We select it and click next. And this is a regression job. So because we are predicting continuous numeric values, since it's the number of bikes and it's not a classification job. So I'm going to choose this. I'm going to change the additional configuration settings. And for the primary metric, this is what is measuring how successful our model has been trained. So I'm going to choose the normalized root mean square error. We don't have to worry too much about the math because there are many different ways to measure this, but we're going to keep it simple. And you can use all the support models to try and train your model, but I'm not going to do that. I don't have all the time, so I'm going to uncheck this and just select random forest and light GBM for testing and training this model. That's it. And for exit criterion, to determine success, I'm either going to train this for half an hour or when our metric score goes below a certain number. So for this, I'm going to say 0.085 as my measure of success. So whichever is achieved first, my model will stop training. I'm going to click Save and also check your featureization. Make sure this is enabled. And click Next. And I'm not going to change any of these and I'm going to hit Finish. And this is going to start creating a new automated ML job. And that's all there is to it. So right now we're going to start training our model and soon we'll be able to see how successful it is and deploy it and use it. Now that we see that our automated machine learning model has completed, and it tells me why it completed, it stopped running. So it says that it ran for 10 minutes and it exited because it hit one of my exit criterion, which was it hit the metric score threshold of 0.085. So this model has been trained and ready to go. So let's take a look at some of the success metrics. So here under models, we can see the various metrics. So the metrics that we used was normalized root mean square, but there are many other metrics that you could use to determine the success of your model. me go ahead and close that. I'm also going to show you the other explanations. And under explanations, you can see the aggregate feature importance. So this is an explanation of which of the features that we saw earlier played the biggest role in determining the final answer of the rentals. So it seems that working day is the most important factor. So this means, it probably means that weekends or weekdays are one of the most important things to consider. And as we increase the number of features, we see that the other factors don't play as big a role in determining the final rental data, the numbers for the rental. You can see a little bit more of the metrics. So these are all of the metrics that we saw a little earlier. And now let's go ahead and deploy this model. So this model, let's deploy it so that we can consume it and use it for the purpose of prediction. So I'm going to deploy this to a web service. And I'm going to name it Predict Rentals. And the description, I'm going to say Predict Bicycle Rentals. And I'm going to deploy it as a compute container instance type. And I'm going to enable authentication. And I think we are ready to go ahead and deploy this. So this could take a while. Now our model has deployed, so we see that the deployment status has succeeded. Let's go ahead and try and use this. So go to the endpoints, and this is our model. Let's go in there and check it out. So we see that the deployment status is healthy, it has succeeded, and we see this is the REST endpoint. This is how we're going to be able to consume our resource. Let's try to give it a test. So the way to test this would be to input all of the other data except for the rentals data, because the rentals data is the answer, the prediction that we would like to get from the model. So typically how we would test it is we would store some of the original data aside, because we know what exactly happened during that scenario, and so we already know what the answer is. So when we test it, we will see how close the test result is to what actually happened. So here I have some data that I'm going to pass into this input, and we're going to give it a test. And when you click test, it's going to give you this answer. And this is how we start to consume this. And as you start to build out applications and carry out, build out more complicated solutions, this is how you would start to consume your deployment. So you have the REST endpoint, you have your primary key. This information will go into your code, and you could consume this from your application. Let's jump back to our content and continue where we were. Using the Auto ML functionality is really that simple. And what I want you to take away from this lab is that features and labels are vital in planning your data set for machine learning. Automated machine learning is a low-code solution for machine learning, and anybody can make use of their data in impactful ways and deploy prediction models with just a few clicks without knowing intensive statistics or algorithmic knowledge. And I also want you to note that automated machine learning does not involve a drag and drop interface like Designer, so there are two different solutions. Do recall that compute resources are needed to run machine learning model training. Without compute, you cannot train machine learning models. And recall that once a model is trained, it can be evaluated and then deployed for use as an endpoint. With that, we've come to the end of Module 2. In this module, we got introduced to the concept of machine learning. And we heard about 3 types of machine learning. 2 of them were of the supervised kind, namely regression, whose output is a continuous numeric value, and classification, whose output is a category or class of some kind. And the last one was unsupervised machine learning, known as clustering, where you don't provide the labels and you allow the machine to cluster and separate out your data points. And then we discussed Azure machine learning and talked about Azure Machine Learning Designer before diving into the portal for a short tour, and we looked at how to deploy a machine learning model using the Azure Machine Learning Studio, where we trained a bike rental prediction model. So let's all take a 10-minute break to let all of that content sink in and come back prepared to discuss some applications of machine learning and AI in the upcoming 2 modules. So please step away from your computers and phones. I'll see you back here in 10 minutes. Welcome back from the break, folks. I hope you got to move around a little and digest all the information that we covered in the first two relatively heavy modules. In Module 1, we got introduced to the concept of artificial intelligence and the different applications of AI. In Module 2, we got to look at one such application, machine learning, and we got an insight at how we could build out the solution inside of Microsoft Azure. Moving on to Module 3, we'll be exploring the fundamentals of computer vision. Computer vision is one of the core areas of artificial intelligence, with a strong focus on allowing AI to receive visual input and see the world, to make sense of it and allow us to build out applications and solutions. In Lesson 1, we will discuss the concepts around computer vision and how it functions, and then move on to discuss the solutions in Microsoft Azure that can help you to integrate computer vision workloads such as facial detection, object recognition, and analyzing forms, and several others into your own applications in Lesson 2. In the first lesson, I'll talk about what is computer vision and give you an understanding of how computers receive visual input and some common applications of how this input is processed for useful work. So, what is computer vision? How do computers see? Humans, we use biological eyes to see and process images in our brains to understand the world. Computers use cameras to obtain visual input through digital images such as photographs, live camera feeds, or recorded video files, and then process these incoming images and video feeds using software models. AI applications are then further capable of making sense of these images by using patterns that they've observed from past samples, and they assist in carrying out various tasks, such as recognizing what's in the image, sorting out which part of the picture certain objects are occupying, etc. An image is separated into an array of pixel values. This is how it's segmented. And every one of these pixels is providing information in the form of numeric values, indicating the color intensity in every pixel in the image. These values are then used as features by the machine learning or AI to process and understand the image. Each digital image is represented as an array of numeric values indicating the color intensity of each pixel in the image. Sometimes images are converted to grayscale for ease of computation. In the case of color images, there are 3 layers of pixel values for red, green, and blue intensities. You can then use these color intensity values just like any other data as features to train a machine learning model, or to apply transformations and calculations to analyze the image data and find patterns in it. So by processing these images as arrays and using those features to match patterns, computers carry out a variety of tasks. Let's look at some of them. We will look at 6 different applications of computer vision. Most computer vision solutions are built using a combination of machine learning models and some advanced image analysis techniques. They are all based on the visual inputs from the cameras, videos, or images, like you saw on the previous slide. Common applications of computer vision include the following. First, we have image classification. An image classification model uses the features it locates in an image to predict a class label for that image. Essentially, image classification models answer the question, what is this an image of? By observing the array of pixels and their features, an image classification solution is able to match it to past images they have been trained upon. For example, in this image, based on the shape of the vehicle, the color, perhaps the advertisement on top of the vehicle, the algorithm has determined this to be a taxi. Based on data it has been trained with in the past, this is similar to taxis that it has seen in the past. Of course, there are endless applications to this capability. You could recognize fruits, machine parts, damaged machine parts, animals. The possibilities are endless. Second, we have object detection. Object detection models are trained to classify individual objects in the image and to indicate their location within the image as a bounding box. In this image, you can see a bounding box shown where there is the image of the bus, where the car is located, where the cyclists are. For example, you could expand the traffic monitoring solution to detect the presence of multiple classes of vehicles in an image. Object detection models are used to answer the question, what objects are in this image and where are they? Next, we have semantic segmentation. Semantic segmentation models are an advanced kind of model that classify individual pixels in the image based on which object they belong to. Semantic segmentation down to the individual pixel for that identified object. For example, the traffic monitoring solution might use a semantic segmentation model to overlay masks on the image to indicate the pixels that belong to the bus, pixels that belong to the car, pixels that belong to the cyclist with different colors. Semantic segmentation answers the question which pixels belong to which object. Another situation where you might have seen this happening is during a video call on Microsoft Teams. If you were to choose to blur your background, the application would locate every pixel that is you and keep you looking sharp while blurring the rest of your background. When might you use one over the other? As you can imagine, each of these might require a different amount of processing capability. For example, semantic segmentation is going to be much more computationally demanding than the other two. And there are applications which might require each of these capabilities. For example, you can use semantic segmentation in medical scans to identify exact shapes and perhaps positions of tumors so they can be better targeted for treatment. So every application has its own purposes and uses. Next, we have image analysis. You can build on object detection and classification models to perform image analysis, generating captions and tags based on the contents in the image. So it's a combination of these techniques to identify each of the objects in this image and then carry out classification on each object. In this image, you see that it has recognized a person and a dog and a street, and it has put them into a context and says a person with a dog on a street. Next, we have face detection and recognition. Face detection is used to identify the location of human faces in an image. Further analysis can be performed on the faces to determine the location of facial features. And that is how you have those bounding boxes when you're taking a photo, when your camera automatically changes its focus to make sure faces can be sharply seen on photos. And also, when you're tagging on social media, it can provide suggestions based on past tags that you've provided. And last that we're going to share in this session is optical character recognition, or OCR. An OCR model identifies regions of the image that contain text and extracts them. So in this image, we can clearly see Toronto Dominion Bank as the name of the building at the front, as highlighted by the bounding box. So please understand the differences across these 6 applications well, because I'm pretty sure you will be tested on them in the AI-900 examination. And we'll touch a little bit more on each of these in the upcoming presentation. These are the services under each type of vision service, namely computer vision, custom vision, face detection, and form recognizer that you can deploy on Microsoft Azure. And we'll be talking about some of them in the next lesson and performing a computer vision demo at the end of the module. Now that you've looked at some basic concepts of computer vision, let's see some of the services that are available for you to use on Azure. The first of which is the image analysis with computer vision service. Now that we know what cognitive services are, we're going to look at some of them in detail. The computer vision cognitive service provides a pre-trained computer vision model that you can use to analyze images. This pre-trained model can detect and locate over 10,000 classes of common objects. It can then generate an automatic caption for that image and a set of relevant tags that relate to the contents in that image. Tags can be very useful if you need to index images and search for them in the future using relevant keywords. The service can also detect and analyze human faces that show up in the image. The computer vision service can carry out content moderation by identifying images that contain adult, racy, or gory content. We've heard reports of PTSD suffered by human content moderators. So some of this work can instead be offloaded to these cognitive services to free up humans for more value-adding work, or to only be brought in for those instances where the system's confidence level is a bit lower. It can also detect and extract text in an image. We'll explore this more in depth later in the module. Given an image like the one on the right, the computer vision service can analyze the image and generate the following. It can pick up common objects in the image, things like jeans, people, shoes, sidewalks, and tag them. After that, these objects are put into context to generate a suitable caption. Additionally, it can also detect any text or faces in the image and identify the presence of adult, racy, or gory content. In the previous solution, we saw that image analysis can locate over 10,000 classes of objects off the shelf. But what about when you have a very niche application of image analysis? Sure, the computer vision service can recognize a car from an image, but it may not necessarily be able to distinguish a Mercedes from a BMW or a Ferrari. All of them are just going to be identified as a cars. Now let's take a look at custom vision cognitive services, which enables you to train a custom model for either image classification or object detection. You will classify these images yourself to train those models to then be used for future predictions. And in this case, you have to upload the sample images of different types of cars to the custom vision service, for example, and tag them to the appropriate labels. And in this way, you'll be able to train the model on which images to contain a Mercedes, which images contain a BMW, or which ones contain a Ferrari. So the more images you train with, the better the models get at recognizing the object. And after training that model, you can publish it as a service for applications to use. The service provides a web-based portal in which you can upload your own images, label the images or the objects in them. Below, we have labels shown for where the banana, the orange, and apple are clearly defined. Similar to the bounding boxes that we saw earlier around the buses, cars, and cyclists, we can train and deploy the model now. You can then consume the model from a client application using its model ID with the endpoint and key for the resource in which you deployed it. The prediction model can be trained in 3 easy steps before deployment. We just need to upload the images and tag them. We need to train the model and publish and consume the model. Next, we have face detection. Face detection is an area of artificial intelligence in which we use algorithms to locate and analyze human faces in images or video content. Face detection involves identifying regions of an image that contain a human face, typically by returning bounding box coordinates that form a rectangle around the face. Facial analysis moves beyond simple face detection. While the custom vision service provides some basic face detection and analysis, the face service offers additional capabilities, including detecting certain attributes of the face, such as the amount of blurriness of the face in the image, the exposure of the face, whether the detected person is wearing glasses on their face, the 3D orientation of that face, the visual noise detected in an image, and whether there are objects blocking parts of the face. One way that Microsoft has put its fairness and transparency, responsible AI principles into action is with continued updates to the face service. The cognitive services team is retiring face service capabilities that target sensitive attributes, things like age, gender, and emotion, which, if misused, could further discrimination. You can learn more in the link in your additional resources document. Only Microsoft managed customers can continue to access models trained to identify specific individuals based on the location of facial features and models to compare faces for similarity. Common applications of detecting faces include building security and access, social media tagging. For example, Windows Hello on my laptop allows me to log in to my computer using my camera. We've already discussed the computer vision service and its use in image analysis. Now we're going to discuss its optical character recognition capabilities, or OCR for short. OCR is the ability to detect and extract text from images. The ability for computer systems to process written or printed text is an area of artificial intelligence where computer vision begins to overlap with natural language processing. You need computer vision capabilities to read the text, and then you need natural language processing capabilities to make sense of it. The foundation of processing printed text is optical character recognition, in which a model can be trained to recognize individual shapes as letters, numbers, punctuation, or other elements of text. The ability to recognize printed and handwritten text in images is beneficial in many scenarios, such as note-taking, digitizing forms or medical records and documents, scanning printed or handwritten checks for bank deposits. Digitizing allows you to archive and query this data with much greater ease. So you can imagine the benefits of that, especially when it comes to applications like medical data, when you can start to spot patterns in patients' data, things which may not necessarily make sense as a single data point, start to join up when you can use machine learning, and that starts with digitizing data. There are two different services that you can use for this purpose, based on how much text you're trying to convert or extract from that image. OCR API is used for quick extraction of small amounts of text. It is pretty immediate. Or you can use the Read API when you have an image that is mostly text. Things like documents or pages of a book or meeting minutes. Finally, we have the last service that we're going to be looking at, the Form Recognizer. This service builds on the OCR capabilities of the previous example and has the additional ability to conceptualize the form fields. For example, identifying specific types of data such as addresses, phone numbers, dates, times, and quantities. It can also understand the relationship between field labels and values. You can use Form Recognizer to train your own custom form extraction models based on your scanned forms, or you can use the pre-trained receipt model to extract information from scanned receipts. A common problem in many organizations is the need to process receipts or invoice data. For example, a company might have a special form for onboarding new employees, which might require submissions of electronically scanned documents or other information that needs to be digitized and routed to the relevant departments such as legal, HR, and operations. It's relatively easy to scan receipts, to create digital images or PDF documents, and it's possible to use optical character recognition technologies to extract the text or contents from digitized documents. These forms might contain information that needs to be extracted and conceptualized, such as phone numbers, names, dates, addresses, and legal details. The Form Recognizer service in Azure provides intelligent form processing capabilities that you can use to automate the processing of data in documents such as forms, invoice, and receipts. It combines optical character recognition with predictive models that can be interpreted from data by matching field names to values, by processing tables of data, by identifying specific types of data. Now that we've seen various computer vision services available on Azure, let's take one of them for a spin, shall we? Join me in the portal. We find ourselves back in the Azure portal for another demo. So right now we're going to be doing the Analyze Images with Computer Vision. So for that, we need an additional resource. So let's go ahead and create that resource. We can either create the Computer Vision resource or the Cognitive Services General resource. But for this demo, I'm going to create the Computer Vision resource. So I do have some existing demos that I created before with resources. I'm going to create a new one for this session. Just follow the wizard. It's pretty, it guides you quite well. So for the resource group, I'm going to select the same resource group that we've been using the whole time, AI-900 Virtual Training. I'm going to deploy it in the East US region. And the name has to be unique. I'm going to call this analyze images AI-900 demo. Is this unique enough? Perfect. So once you see a check mark, it has allowed the name. And I'm going to have to use the standard resource type because I already have another resource that's using the free tier. So that's okay. It doesn't cost too much. And I think that's all the setup that you need, but you do need to accept the responsible AI notice because Microsoft does practice responsibility when building out AI solutions or allowing customers to use these AI solutions. So we do need to accept and acknowledge the above terms. And we can go ahead and create this resource. After I click Review plus Create, so our deployment is complete. Now we can go to the resource. So this deployment is no different from what we did in Module 1, where we looked at the keys and endpoints for cognitive services. And that is how you're going to be able to consume this resource as well. So we have the keys and the endpoint. That is how we're going to be sending requests to this resource. And I'm going to use the Cloud Shell once again to carry out this operation. So let's go into the code editor and modify this code. So I'm going to go ahead and open the script that is relevant for this image analysis, and that is analyze-images, that is right here. And what we need to do is we need to replace the key and the endpoint with the data that is in our resource over here that we just created. So let me go ahead and do that. So copy the key and we replace it. And we need to copy the endpoint and replace that. So make sure no one is able to see your specific key and endpoint because it does charge you when this resource is used. I'm going to save this, save and close. So if you don't want to use the buttons, you can use the shortcuts Control S and Control Q to close the editor. And now we're back in our command line. And I'm going to deploy this resource. So now that we've replaced the key and the endpoint, we can go ahead and deploy this resource. And to analyze an image, we do have some images that are stored inside that GitHub repository that I'm going to be using. I'll show you how the image looks when I'm about to run that script. So first thing we need to do is we need to navigate into that folder. AI-900 virtual training. Once we're in this folder, we are ready to run the script. But let me bring up that image so that you can see which image I'm going to be analyzing. So this is the image I'm going to be analyzing, and let's run the script and send this image to the endpoint. To run the script, I need to write analyze-image.ps1 space, and then the name of this image is store-camera-1.jpg. So I'm just going to make this window a little bigger because there's going to be quite a bit of content that it will generate. And when I hit enter, it's going to analyze this image. And it's going to tell me a bunch of things. So it's going to give me a description of a woman showing her phone to a child. That's what's happening in this image. And we have all the other objects in this image. Things like cell phone, two people that have been recognized, the room, and all the tags. Things like text. So it found text somewhere, probably in the background, over here maybe on the labels, and the person that has been tagged, the woman, the store, and the shop. Let's try this again with another image. Okay, we've pulled up another image. I'm going to run the same script, but this time with image number 2. Let's see what happens here. And now we have a different description. So it has understood contextually what is going on in this image. A woman holding a shopping cart. So this is not exactly accurate. She is holding a basket, but it did recognize it as a card because it contextualized based on all of the tags that it found in the image. And it found only just a person in this image and nothing else. So this could be due to the blur in the background or the angle where the photo was taken from. Let's give it one more try and see how well it performs. Let's try a third image. And here we have another image of a lady shopping at a supermarket, and let's see what our image analysis resource can provide. And here it says a person pushing a shopping cart, a little bit more accurate. And it found two objects, a person, the supermarket, and all of those tags. And you can begin to see this is a very simple example, but in the real world, you can see how powerful this could actually become. You could have an example or an application where safety is something they can monitor, whether someone is wearing a helmet or not, or if a car is traveling at high speed, for example. When you compare from one image to another, that could be a potential risk. So all of these things can be done with image analysis. So let's jump back to our presentation and continue towards the end of the module. You can see how useful and powerful image analysis can be for applications like self-driving cars, safety and security, amongst many others. With that, we've come to the end of Module 3. In Module 3, we looked at concepts of computer vision and saw various applications of the technology in Lesson 1. And in Lesson 2, we looked at some Azure-specific services that can help you to build out solutions to carry out those workloads. I'd like to now send you off for another 10 minutes to ponder how useful a role AI might play in our future. And I'll see you back right here for Module 4, where we will be talking about another useful technology which helps computers to speak our language. Go get your coffee, tea, or drink of choice, and I'll see you soon for Module 4. Welcome back from the break. I hope you're ready to go because this is my favorite slice of the AI pie to talk about. And I'm excited to share that with all of you. Let's get started with natural language processing, or NLP for short. In this module, we'll start with an introduction to natural language processing, and then we'll move on to talk about the specific services inside of Azure that will help to execute NLP workloads, which will be covered in the section about natural language solutions. In this session, we will be discussing several of them, and you will need to understand their purpose for the exam. Let's dive right into Lesson 1, Introduction to Natural Language Processing. Natural language processing, or NLP, is the area of AI that deals with making sense of written and spoken language. On the screen, we see a list of common NLP tasks. Let me start by talking about the first one, text analysis and entity recognition. Often, you need to analyze a text document to determine its important features or identify entities that it mentions. Entities could be things like dates, places, people. For example, a company might use AI to analyze industry magazine articles to try and find articles that mention their products or their executives, or maybe to determine the main subject of each article. Or you may have noticed in emails how some key phrases are automatically underlined, such as dates, which might allow you to automatically set a calendar event. That is an application of NLP. Second, we have sentiment analysis. This is a common form of text analysis that calculates a score indicating how positive or negative a text extract is. This service can evaluate text and return sentiment scores and labels for each sentence. This capability is useful for detecting positive and negative sentiment in social media, customer reviews, discussion forums, and many other avenues. Using the pre-built machine learning classification model, the service evaluates the text and returns a sentiment score in the range of 0 to 1, with values closer to 1 being positive sentiments, and scores that are close to the middle of 0.5 are considered neutral or indeterminate. For example, if there was a restaurant review that sounded like, "We had dinner at this restaurant last night, and the first thing I noticed was how courteous the staff was. We were greeted in a friendly manner and taken to our table right away. The table was clean, the chairs were comfortable, and the food was amazing." The sentiment score might be closer to 0.9 or even 1, indicating a very positive sentiment. Whereas a review that goes like, "Our dining experience at this restaurant was one of the worst I've ever had. The service was slow, the food was awful. I'll never eat at this establishment again." Because of the usage of the words and the emotions that seem to indicate a negative experience, the score for this second review might be closer to 0 or 0.1, indicating a negative sentiment. Next, we have speech recognition and synthesis. It's becoming increasingly common to encounter AI systems that can recognize spoken language as an input and synthesize spoken output. This is applied in smart speakers and digital assistants on our phones that accept vocal commands and are able to provide spoken responses. Consider the growing number of home and auto systems that you can control by speaking to them, by issuing commands such as "turn off the light," and soliciting verbal answers to questions like, "Will it rain today?" So for example, your smart AI assistant can automatically start or stop music when you're driving to enable hands-free communication, or allow you to respond to a text by dictating a reply to enable hands-free communication. And number 4, we have machine translation. Nowadays, as we start to work more across cultural and geographical boundaries, it is required our ability to eliminate language barriers. And AI can be used to automate translation of written and spoken language. An example of this might be an inbox add-in that could automatically translate incoming or outgoing emails, or a conference call presentation system might provide a simultaneous transcript of the speaker's words in multiple languages. I've personally been in meetings where I've had participants who have spoken in Mandarin, English, Japanese, and German, and we were all able to use the Microsoft Translator to understand each other in real time. This allows us to be inclusive and sensitive to other cultures. And finally, we have semantic language modeling. Language can be complex and nuanced. So the multiple phrases might be used to mean the same thing. For example, a driver on the highway might ask a smart assistant on her phone, "Where can I get gas near here?" And this means the same thing as, "I'm running out of petrol." Or it could be providing the same answer as when she asks, "I need to buy water." All of those could essentially mean that she's looking for a petrol station or a gas station nearby. So a semantic understanding of the language being used is required to discern what the driver needs. An automobile manufacturer could train a language model to understand phrases like these and respond by displaying appropriate navigation directions to the nearest petrol station. Based on the possible tasks that machines can accomplish when it comes to processing language, all of these that I've just mentioned are also available for you to deploy to your own applications and workloads using Azure's off-the-shelf solutions. Let's begin by talking about conversational AI. Conversational AI is a solution that enables dialogue between an AI agent and a human. Conversational AI builds on other AI workloads, in particular, natural language processing. But it also has elements of machine learning and sometimes, potentially, computer vision as well. And in general, when people use the term conversational AI, they are referring to bots. People often associate the term bot with a chat interface on a website, but that is just one very common way to interact with a bot. Bots can also be connected to multiple channels, including email, social media, to the telephone, and so on. Bots are used in multiple different scenarios, such as customer support, for example, answering frequently asked questions, or gathering information before handing it off to a human customer service representative. You also find them in reservation systems. For example, it enables users to book cinema tickets or flight tickets, maybe even restaurant tables. We find bots in digital assistants. For example, an in-home or a phone-based virtual assistant that can perform tasks based on certain instructions. We can find them in online ordering as well. For example, when you order takeout food or for delivery or products from an online retailer, you're going to be able to sometimes encounter bots. And sometimes we also find healthcare bots. These healthcare bots can provide an automated diagnosis based on symptoms. And we find bots that help us to improve our office productivity, to find relevant corporate resources for a task. So why do we need to use bots? Humans are obviously much better at understanding nuanced, difficult questions. So they should be freed up to tackle more value-adding queries and doubts, not the usual frequently asked questions like, what time are you open? Or how much is product X? Where are you located? Humans waste a lot of time answering these simple questions when they could easily be found elsewhere. The example shown on the right side of the screen is a chat interface, such as one you might find on a website. But bots can be designed to work across multiple channels, as I mentioned. Regardless of the channel that these bots are deployed, bots typically manage conversational flows using a combination of NLP and constrained option responses that guide the user to a resolution. These conversations usually take the form of a message exchange in turns. And one of the most common kinds of conversational exchange is a question followed by an answer. This pattern forms the basis for many user support bots and can often be based on existing FAQ documentation. So to implement this kind of a solution, you would need to build a knowledge base of question and answer pairs, usually with some built-in natural language processing model to enable the questions to be phrased in multiple ways. Because these questions all mean the same thing and are going to require the same answer. So essentially, a bot service provides an interface to this knowledge base through one or more channels to be able to find that answer for the user. Azure's off-the-shelf services can help you to develop solutions and go to market and be more agile to reach your customers without having to reinvent the wheel and build a language model from scratch. The services you see on the screen are available on Azure and will allow you to start building and deploying your own NLP solutions immediately. They fall into the categories that we just discussed. Let's look at a few of them and see a demo of how we can analyze a piece of text using the language service towards the end of the module. On to lesson 2, the final lesson for today. We're going to look at how to build natural language solutions in Azure. Now let's look at some NLP solutions that are ready to use off the shelf. We start with text analytics. Text analytics is a capability in language service that is used to analyze input text documents. When we read a sentence, we are looking out for several things like what are the key phrases in the text? What are perhaps some names and references? Is there some emotion being expressed by the text? Those are all things that humans notice very well. Our challenge now is to get AI to try and do the same thing. And it is very complicated to program it from scratch. So being able to use them off the shelf greatly simplifies your development process. If you're trying to create something new for your marketing, for your document analysis, maybe your social media management, or any other purpose that you can think of that you might be using it for. Suppose you can use text analytics to analyze the text on the screen. I had a wonderful vacation in France. Generally quite positive, but let's see how it would get analyzed. So the first thing that will be analyzed is the language. The service determines the language that the text is written in, so it has high confidence that it is written in English. Next, we are able to get the sentiment of the text. In this case, it was largely positive, 88% positivity. So in a scale of 0 to 1, it would fall at 0.88. Next, we also find key phrases, and the key phrase here is wonderful vacation. And finally, you can pick up entities in the statement. And the entities here are France. This is a very simple example. But imagine if you had to analyze Twitter for mentions of your brand or your company, and you have several thousand comments to analyze. A service like this would greatly speed up the process and help you to analyze your data and harvest the information in a much quicker manner to draw any insight that you need to take future action. The next service we're going to be looking at is speech recognition and synthesis. This is concerned with vocal commands and spoken responses. Recognition refers to the ability to recognize, detect, interpret spoken input. And synthesis is the ability to generate spoken input, to form sentences rather. So think smart speakers, AI assistants that recognize when you ask them to turn off the lights, or they recognize when you ask them to play a song by speaking to them, and they can also synthesize appropriate responses to you, like when they do find the song, or when they cannot find the song, they apologize to you. The speech service provides a speech-to-text API to perform real-time or batch transcription of audio into text. This service supports text transcription in more than 60 languages. Conversely, the text-to-speech API can synthesize audible speech from text, with the option to specify regionally appropriate voices for human-like pronunciation. When you use the text-to-speech API, you can specify the voice to be used to vocalize the text. This capability offers you the flexibility to personalize your speech synthesis solution and give it a specific character. The service includes multiple predefined voices with support for many languages and regional pronunciation, including standard voices as well as neural voices that leverage neural networks to overcome common limitation in speech synthesis regarding intonation, resulting in a more natural sounding voice. You can also develop custom voices and use them with the text-to-speech API. As organizations and individuals increasingly start to collaborate with people from other cultures, we need to remove language barriers because it has become a significant blocker. And one solution is to find bilingual or even multilingual people to translate between languages. However, that kind of a skill is quite a scarcity. And the number of possible language combinations can make this approach difficult to scale. And increasingly, automated translation, sometimes known as machine translation, is being employed to solve this problem. Decades ago, if you had used any of these translation services, you may have noticed how the translation was often literal, sometimes word for word, which can lead to some embarrassing and funny situations. With advancements in the field of AI, semantic context has allowed the service to return a more accurate translation of the input phrase or phrases. The grammar rules, formal versus informal, and colloquialisms all need to be considered when you are talking about language. For example, in English, we say, I kicked ball. And in my mother tongue of Tamil, the order is slightly different. It would be arranged I, ball, kick. So slightly different. And the translated text service enables you to translate text between more than 60 languages. You can also translate audible speech by using the speech service, which can produce translated output in text or audio format. It can also output both speech and text from the input speech. The language understanding service enables you to train a language model that can interpret natural language commands. As artificial intelligence gets smarter, interactions with applications and digital assistants are becoming more commonplace. And in specific scenarios, can result in human-like interactions with AI agents. Common scenarios for this kind of solution include customer support applications, reservation systems, and home automation, amongst others. To enable these kinds of conversational solution, computers need to be able to accept language as input, either in text or audio format, while also being able to interpret the semantic meaning of the input and understand what is being said. On Microsoft Azure, language understanding is supported through the Language Understanding Service. To work with the Language Understanding Service, you need to consider 3 core concepts, and you will need to know them for the examination. First are utterances. Utterances are phrases that a user might say or type. For example, switch the light on. That's an utterance. Entities. Entities are specific items that are referenced in an utterance. For example, a language model for a home automation application might recognize household devices such as a light or a fan. And finally, intent. Intent identifies the desired action or the goal of an utterance. And in this example, it is to switch the light on, to switch something on. Common scenarios for this kind of solution include automated phone banking and smart homes. And then we come to question answering. This cognitive service enables you to create and publish a knowledge base that is a question and answer bank, usually with some built-in natural language processing model that enables questions to be phrased in multiple ways to be understood with the same semantic meaning. You can use the Q&A Maker portal to create this knowledge base that consists of these question and answer pairs. These questions and answers can either be entered and edited manually, or they can be generated from an existing FAQ document or web page, or they can be imported from a predefined chit-chat data source. And in many cases, a knowledge base is created using a combination of all of these techniques, extending the knowledge base with additional manual entries. Questions in the knowledge base can be assigned alternative phrasing to help consolidate questions with the same meaning. For example, you might include a question like, how can I visit your head office? And you can anticipate by adding an alternative phrasing such as, where is your head office? Different words, same meaning, same question. After creating a set of question and answer pairs, you must train your knowledge base. This process analyzes your literal questions and answers and applies a built-in natural language processing model to match appropriate answers to questions, even when they're not phrased exactly as specified in your question definitions. After this training, you can use the built-in test interface in the Q&A Maker portal to test your knowledge base by submitting questions and reviewing if the right answers are being returned. And you can go ahead and publish it so that the client applications can use it. That is the Q&A Maker. And then we have conversational AI solutions that focus on interactions between human users and AI agents. And these are called bots, which brings us to the Azure Bot Service. There are several ways where we can deliver a conversational AI solution. It could be using a client application or a bot. By encouraging our users to interact with the AI agent, we free up our human agents to do more value-adding network. And a bot developer can use several tools to develop and build a bot, including using Power Virtual Agents, Bot Framework Composer, or Bot Framework SDK. This bot then gets integrated with the Azure Bot Service and the Azure Cognitive Services in the cloud. So the bot can make use of capabilities such as question answering and get published. A bot is an application with a conversational interface, so they could be deployed on a whole host of deployment channels, such as a web chat, an email, Microsoft Teams, and others. With that, we come to the end of Module 4. But before that, let's jump into the Azure portal one last time to see a language service demo. Shall we? So once again, we shall go into the Azure portal to create another service. This time we're going to be doing some analysis of language. And for that, there's another special service. It is the language service. So let's go ahead and select that. Language service, again, is a standalone service, not like the general cognitive services which can be used for all services. I'm going to create this. And when you're selecting the language service, you can select additional features. So if you were building a bot, for example, you would select the custom question answering. Or if you had some specific niche requirements, you might require custom text classification and named entity recognition. But this time we're just doing very straightforward analysis, so these default features are sufficient. So I'm not going to select either of these. I'm going to go ahead to continue to create my resource. So again, I'm selecting my own subscription, and for resource group, I'm going to use the one that we've been using for this entire demo session. And I'm going to deploy it in the East US region. I'm going to give it a name, Language Service AI-900 Demo. Make it nice and easy to recognize in the future. For the pricing tier, I'm going to select free since it's available. And of course, you need to accept the responsible AI notice. I'm going to accept this, and we can go ahead and review and create this service. Simple as that. So when you click review and create, it will validate that you are allowed to create this resource and all the configuration is proper. And go ahead and click create. Our deployment is now complete, and we can go ahead and use this resource. Let's go ahead and consume this language resource. And once again, we're going to do the same thing that we did in the previous demos. We're going to go and find the keys and endpoint. This is how you're going to be able to access and use this resource. And let's jump into our Cloud Shell again to modify this code and this script. I'm going to jump into my code editor and modify this code. And this time we are using the analyze text script. It's again inside there, analyze text. And we need to replace the key and the endpoint. Nice and easy. So you can use either key, it's perfectly fine. I can use key 2, it will give me the same results as key 1. And replace my endpoint as well. And that's it, we are ready to go. So let me go ahead and save this and close the editor. So there's some text that I'm analyzing. I mentioned that it's a review that I'm analyzing. So let's pull up that review so that you can see it side by side. So on the right, you see the review text that's going to be sent to this language service. I'm going to expand my Cloud Shell a little bit more because there's going to be a bit of information that we're going to get. And the review says it's a good hotel and staff, the Royal Hotel, clean rooms, good service, great location near Buckingham Palace and Westminster Abbey, and so on. So generally a very positive review. So if we feed this into our language service, let's see what we find out. When we analyze text.ps1, so this is the script that we're going to be consuming, and this is the review that we want to analyze, review1.txt. All of this is inside the folder in our Cloud Shell. So when I hit enter, it's going to do a couple of things. So first you see it detects language, it finds key phrases, it analyzes sentiment, and it found known entities. So let's go up and read all of this stuff. And just to highlight, you don't have to do this inside Cloud Shell. You could do it from an application that you're building, you could do it from your own computer, a web application. There's many ways to consume this service. I'm just doing it in the Cloud Shell. So first, it found that it detected the language. So it has a 99% confidence score that this is an English review. So yeah, I think that's pretty accurate. And then it found key phrases throughout the entire review. So things like the Royal Hotel, Buckingham Palace, Westminster Abbey, Michelin star, anything that a human reading this, their attention may be attracted towards those things, the AI also picked up. So it dropped out words like we and went and to, so on. Those are kind of unnecessary words. They don't really add that value. They're just for the purpose of grammar. And then we have the sentiment of this review. So its sentiment is a positive sentiment based on these scores. So 98% positive, 1% neutral, and 1% negative. And it identified known entities. So the entities that it recognized are good music, hotel, Royal Hotel. So if you're doing some research, this would be a very useful way to go about doing that. Now let's go ahead and feed another review to this script. So this is another review, also of the same Royal Hotel, but this time not so positive. So it says tired hotel with poor service, the Royal Hotel, London. This is an old hotel and the furnishings are average, becoming a bit old now and require changing. So let's feed this review into our script and see what happens. I'm just going to modify the previous command that I did. So I'm going to send it to analyze text.ps1 review 2 and hit enter. It's going to do the same couple of things, detecting language, finding key phrases, sentiment, and identifying known entities. So a little different this time. Let's go up and go through this again. So again, it detected the language, and this time it's 100% certain that it is English indeed. And then it found key phrases, again, Royal Hotel, tired hotel, old hotel. So all generally negative things that it picked up, and some entities that it recognized. And then it analyzed the sentiment, and this time we have a very different sentiment. It's a negative sentiment based on these scores. 1% positive, 7% neutral, and 92% negative. And this would be quite accurate. This is the same feeling that I would get if I was reading it. And the known entities have also been given Wikipedia links for you to do some research on. And this is how you will be able to use this service. And you can imagine using this for many other applications. For this example, if you said a human could read it and understand it, I agree with you. But imagine if you were trying to understand the sentiment or that the world was thinking about your company, and you had to go to Twitter and you picked up 1 million comments. And could we sit down and really go through one by one all of those and figure out whether it's a positive or negative sentiment? So applications like that, the language service can really come in handy to help carry out this job. So often it is used in marketing, it's used in analysis of sentiments. And so let's go back into our portal and wrap up this module. As you can see, the language service is a very useful tool with a lot of potential for building applications. So go ahead and try to build something yourself to see how easy it truly is. And that is a wrap for Module 4. In Lesson 1, we got introduced to the concept of natural language processing, and we had a short discussion about NLP and conversational AI. Following that, in Lesson 2, we saw several NLP solutions inside of Azure, such as text analysis, speech recognition and synthesis, translation, and Azure Bot Service. Which brings us to the end of today's session. I would like to thank you for attending this session. Artificial intelligence is a huge topic, and today's session is just the first step in this long journey. I hope you have found this session useful and have a greater appreciation for AI. And since you've stuck with me through to the end of this session, I highly recommend signing up for the AI-900 examination. The questions are going to come from the same great content that we've covered across these 4 modules. And since it is a fundamentals course, you only really need to focus on identifying and describing the different AI components inside of Azure. I highly recommend that you check out aka.ms/AzureLearn_AI fundamentals to revise the content that I've covered in today's session. I wish you all the very best as you prepare for the AI-900 examinations. I think that's pretty much everything that you need to know while preparing for the examination. Again, review any areas that you might be unsure about with the learning path at aka.ms/AzureLearn_AI fundamentals. And make sure that you share that shiny new badge on LinkedIn once you pass your exams. Once again, thank you so much for taking the time out of your schedule to join us for this session. Good luck with your exam, and I hope you have a fantastic rest of your day. And hopefully we'll be celebrating a new. See you in another class really soon. Bye everyone.